Welcome everybody to our Stormwater Awareness Week class on LID. My name is Jonas Sonner. I am with WGR Southwest. I'm going to be kind of facilitating this workshop. And our presenter here is, let me find your last name. It's Mitch Whitson with, well, I'll let him talk about his company here. Do you want to give your introduction, Mitch?
Sure, it's part of the presentation. My name is Mitch Whitson with California Filtration and Whitson Contracting and Management.
Great, and so I'll give a quick introduction on Stormwater Awareness Week. We do this annual event. We try to put on an annual event every year to bring free stormwater education to different industries across California. And we try to host workshops for industrial, construction, and municipal stormwater related issues. And we have been doing this for about 7 or 8 years now. And COVID tried to stop it this year, but we decided to try and do it all online. So thank you all for trying to participate and joining us this morning. And I think with that, Mitch, I'll let you go ahead and get started.
Great. Can you see my screen?
Yes, and we can see your PowerPoint now.
Nice. Okay. Ton to go over. I don't know who the participants are, so I apologize if some of this is redundant, keeping with the theme of sticking with education. I didn't want to dive right into products and what we do, which is, I think, the theme of it. So my name is Mitch Whitson. I'm the Director of Business Operations of California Filtration Specialists. It's one of the companies that my wife and I own. Audrey owns this business, so it's a woman-owned business enterprise. We founded California Filtration Specialists, really through the evolution of our companies. So in a nutshell, we started off about 18 years ago as a heavy civil construction management firm. I'm one of those Cal Poly's construction management grads. I've been doing nothing but heavy site civil construction management since the late 80s. So roads, bridges, anything outside of a building, we have good experience in. When you're in this business, and I bring this background up for a couple different reasons, because one is when you're in the site development business, in the public works enterprise, you're always dealing with permits. You're dealing with fish and game permits. You're dealing with Corps of Engineers permits. You're dealing with water permits. So it's always been ancillary to what we do. And my philosophy as a construction manager is, if you're not satisfying all of your customers, and that's not just the person that hired you to build the road, that's the water board, that's the utility agency, that's the public, if everyone's not 100% satisfied, then you have a failed project. So we've always paid attention to those permits, because those permits really do affect how we build roads and how we build bridges. So we've always been involved with that. So we're a heavy civil CM firm. We still are. We do a lot of design build stormwater projects. So if you guys anyone in the call, if you guys get us involved early, and I'll probably say that 5 or 6 times. If you have a very conceptual layout, before you even do the water quality management plan, talk to us, because that's where we can affect change and affect value in your project more than any other time. We can absolutely save you money after the fact, but it's better to start with the design that has conceptually incorporated low impact development, which is ultimately what we're trying to do, because we've proven time and time again, if you implement solid low impact development technologies, you're going to reduce the cost of the project. You're going to reduce the maintenance of the project. That's just a fact, and it's been proven time and time again. So we've always been a heavy civil CM firm. Normally when I do these presentations, I'm talking about stormwater permit compliance, and that's what I've done in the past, industrial construction. So Whitson Contracting and Management, about 95% of what we do is construction, industrial, municipal stormwater compliance. Any of our construction management projects typically revolve around a design build project for a tank system or something along those lines. So we're embedded in the stormwater market. So sticking with the educational vein, I'm going to stick with just concepts for most of it. I'll go over some things at the end. I'll go through it very quickly because I won't have a ton of time. But, you know, what do we want to do? I mean, what is the number one goal in stormwater management? And it's infiltration. And the reason it's infiltration is because you get two benefits from infiltrating that water. One is it recharges our aquifer. It also reduces runoff on properties. So, you know, if you're able to get that water into the ground, you're reducing the runoff off of that project. But A, it recharges our aquifers, but more importantly what it does, or as importantly what it does, is it treats the pollutants in that stormwater. If you look at a traditional septic system, you know, they say that, you know, I've read several articles that somewhere between 8 and 10 feet below a septic system in fairly good organic soils, that water is potable, you know, and that's because of the root structure of all the plants and vegetation. It's because of the anaerobic bacteria action of the soils. The soil itself isn't dead. The soil actually converts all of those pollutants into food for, you know, again, bacteria and root structures of things. So by the time it gets deep, it's clean. That's why groundwater generally is pretty clean unless you are stupid and you put some chemicals into the ground. You know, so for a long time we've thought about, hey, let's go ahead and do dry wells. We're going to, you know, dry wells. Well, the problem with dry wells, or for my biggest issue with them, is it's generally a direct path. What you've done is you've shortened that separation distance between the water table and the dry well, and you basically separated that distance, so there's less area for that water to be treated. More importantly, those pollutants aren't going through, they're going directly down to the source. So, you know, a lot of people, certainly up in the Central Valley of California, they're getting rid of dry wells because they just found that it's causing as many problems as not. Also, this is kind of a misnomer. It shows that water infiltrates on the side. Not really. You know, the water, 98% of the water that goes through a system is through the bottom of that system because the weight of the water is kind of forcing it. You're getting very, if no, infiltration at the very top of the system. So they're expensive. They don't really work. They're costly to maintain. It's a hole in the ground filled with rock. And I see some people put these fancy little structures on them, which is okay, great. Well, if we're really trying to infiltrate, you know, there are technologies. And if you guys are interested, please hit me back up because we can get into some deep dives of different types of technology. In fact, we host webinars every Wednesday at noon that we go over permeable paving systems, low impact development, just the same presentation, permeable paving, structural solutions, storage infiltration systems, and filtration systems, and a running loop. So every Wednesday we have a webinar. But one of the technologies that we talk about in our infiltration and storage thing is a product called Parjana. Parjana is really neat. It's difficult for me to even get into it in this very short time frame, but in essence what we're doing is we're drilling basically, you know, 1 3/4 inch holes. We're putting an 1.5 inch tubule in there. And what happens is that we put caps on top of them, and then you get this micro collapse around each of these. And what happens is it's allowing water to leave this top area and flow down the tubule and start to saturate this zone. But because they're put in a 2-foot grid and there's 5s, 10s, 20s, and 40-foot grids put out, we're changing the flow characteristics in impermeable soils. So we're taking systems, and we got a job going on in Stockton where, you know, we took a basically less than I think it was 0.03 inches per hour, and we're going to bring it up to just about 1 inch per hour for $200,000, which it seems like a lot of money, but considering the tank size reduction because we now create infiltration. Here's an example of the power of the technology. This is a job that was done for the city of Fresno. They did pre-Parjana. They had an infiltration basin. They were losing all of their water due to basically evaporation. 70% of the water in that recharge basin was being lost to infiltration. When they installed, and then so over the span of 2,500 days, you know, several years, they only infiltrated 29.82 acre feet. Within less than a year of doing the Parjana system, and they're testing the groundwater. There's no direct path from the top to the bottom. It's going through the soil, so it's actually being treated as it goes through the system. We've now infiltrated 69.72 acre feet of water in less than a year. So instead of only infiltrating 30% of the water, we're now infiltrating 90.47% of the water. So there are technologies when you do have non-permeable soils that you can implement technology to actually permeate and actually good infiltration. So again, fairly complicated. This is a presentation all on its own. If you guys are interested, let me know, but this is a really neat system. It's changing the way we're managing projects. We're reducing tank sizes, we're reducing basin sizes. We're doing some pretty significant things with this technology. If you can't infiltrate, then somebody a long time ago coined the phrase bioretention. So let's just do a bioretention basin. We're going to mimic nature. You know, I don't like the term bioretention. And the reason I don't like the term bioretention is because what they've done is they've combined two distinct concepts, two separate concepts. One is water quality, one is volume reduction, runoff reduction. And they tied these two at the hip, and they said that they're not interchangeable. You can take these apart, and you should take these apart, because you don't necessarily have to have a 5-inch per hour basin to work. In fact, you know, I just built a winery project we were the construction managers on in Riverside County, and you know, we're looking at it's got an industrial general permit. So we've got to deal with phosphates, we've got to deal with nitrogen, nutrients, those types of things that come off industrial properties. We're discharging into a water body that's impaired for nutrients. And they say, okay, you have to do this basin that's 5 inches an hour, and the county spec is 60% sand, 40% compost, or 40% topsoil. Okay, prove to me that that's going to reduce pollutants. Also, more importantly, what happens when compost dries up and then gets wet and dries up and gets wet? It reduces nitrates. It produces nitrates. It releases nitrates. So you're actually forcing us, because you've got this dumb bland recipe that you've got to do topsoil and sand, but there's no proof that it actually works. You know, there's probably some studies, but the system that I put in on my project, and I used a certain blend out of some guy from Orange County, or actually Corona, show me the test data. I talked to all of these guys that produce this compost mix, this bioretention mix. Ask any of them for lab results. You know, you're not going to get a very good response, because what they're doing is they're following a blend, and there's no proof in the pudding. So going with a high flow biofiltration that actually has to go through tape certifications, actually has to go through studies, and actually prove in the field that they work, is a better solution. So why are we going to old school? Why are we taking acres of land? Why are we taking lots? It's ridiculous. We shouldn't be doing it. So anyways, you can treat water quality at a high flow rate. In fact, you're going to get better results. You don't have to go 5 inches an hour to control the water. So they've taken two concepts, they've forced the two together, and that's just not a good equation in my mind. It takes a lot of land. So I'm sorry. So biofiltration, you know, we're 20 to 30 times smaller, our footprint. So we've done developments where we've given people as many as 20 lots back. We've got a job in Orange County where we went from a 2-acre bioretention basin, is now a soccer field, a dog park, a tot lot, and I think it's about 7,000 square feet of our focal point above an expanded R tank, which handles all the water quality, water volume. So we've given them back 2.5 acres of land. So instead of a blight on your project, they actually have usable space, which is an amenity. Anyways, I'm going to keep going there. So we do have high flow biofiltration. You do not have to go low and slow. Sorry, I don't like animations. We also have a biocarbon. So we have a tape certified high flow biofiltration called Focal Point. Focal Point is basically Filterra without a box. The gentleman that invented Filterra invented our media simultaneously. Filterra's patents revolve around their box. but you don't want media in a box. Why do Filterra systems fail? Because you're putting a tree in a concrete box. So anyways, same media, same results. In fact, better results. I'll show you some information in a moment. But yeah, we do have a solution, high flow biofiltration, not in a box. We also have a high flow biocarbon solution. We're going through the process of finalizing our submission for tape, but it's a proprietary blend of biocarbon. Carbon's awesome. And the reason why we really like carbon is, think about your Brita water filter. Think about the water filter in your office. That's carbon. That's all it is. The reason carbon's gotten a bad rap is because there's no consistency in the process of producing it, and there's no consistency in the source material. We only use evergreen biocarbon out of the out of the East Coast. It's a very consistent source. It's a very consistent manufacturing process. More importantly, all of the information, all of the studies, all of the universities, they all use evergreen biocarbon. So when you're reading papers on carbon, you're reading on the only source we use, which is evergreen. But it captures everything, and it captures everything because of the cell. You basically take organic material, you cook it at 1700 degrees, it pops all those individual cells. 1 cubic yard of biocarbon has 36 square miles of surface area. So it captures everything, methanes, hydrocarbons. It actually treats CODs. Our blend actually is specifically made to treat COD and BOD at wastewater facilities. So anyways, great product. Let us know. Better for industrial applications because we don't have tape certification on it or an equivalent study, but we're in the process of doing that. Filtration. So if you can't infiltrate and you can't biofilter, that's why you never see this in the development side, because the lowest letter in that rung, the lowest chain is filtration. So filtration it works, but the problem is it's a very site-specific, pollutant-specific model. What are you trying to treat? Because different pollutants capture things for different things. So are you impacting? Are you intercepting? Are you absorbing? Are you doing ion exchange? Are you capturing? There's various technologies of filtration, so it's a very site-specific, pollutant-specific model. We've got some cool filtration products. We've got the only licensed or certified antibacterial filter in the state of California. And the reason is, it's a fab coat, it's called FabGuard. It actually kills the bacteria. So the reason no one else has California Department of Pesticide Regulations certification for bacteria, because it's some type of capture or absorption technology. So you're capturing the bacteria. You don't want to become a bacteria bed. Our Fabco system actually kills the bacteria. That's why it works. So we have filtration products. Continuing along the vein of low impact development. This is a pretty important concept. Decentralization. So what are we doing? We've always designed storm drain systems by capturing that water, piping it to a standard pipe, piping it off that job. Old school technology, understand, but you go 12 inch, 15, 18, 48, and then you do that for a lot of reasons. One is you want to limit the number of discharge locations from a particular property. You also don't want dozens and dozens of manholes leaving a property because it's costly. You want a single 1 or 2 points of discharge off of a project. Well, then all of a sudden we come around and we start changing, like, hey, guess what? In 2009, the runoff coefficient off a project pre and post development should not try to be equal. They must be equal. So what did we do? We started building septic systems. We started taking lots. We started doing basins. Okay, these are 60% efficient, because you've got 40% void space and you've got these pipes. So it's basically about 60%, I think it's a little over 60% efficiency of the system itself, what the void capacity of the system is. We could do that. We could do it with an R tank. We're going to reduce the size of your system. And the reason is we're 95% void space. So instead of 60%, we're going to reduce you by a minimum of 1/3. More importantly, we're not bound to be a wide flat system. We can make it look like wherever we want. Oh, but it's also modular, so we can put it wherever we want. So why are we taking lots? Why are we building big septic systems on projects? Why are we building vaults? It's ridiculous. We shouldn't be. We should be treating DMA by DMA. We should be taking the individual drainage management areas, we should be treating at the source, and we should be containing at that source. Because what it's done is you've gotten rid of that vault. But as importantly, where's my storm drain system? You're eliminating your storm drain systems, or at a very minimum, you're reducing the size of your storm drain system. So when I capture the water in this drainage management area, I can do my biofiltration through a focal point right here on this guy's, right here in his planter bed around his park or in the front of his driveway. I can do an expanded R tank underneath, and I basically captured both the water quality and the water volume off of this lot before it leaves. So even if there is a storm drain system, that storm drain system is going to be greatly reduced in size at a very minimum. So decentralization is a key concept when it comes to low impact development, and we need to really pay attention to that. Stop piping things to a big vault. Stop piping things to a septic system. It's silly. There's no reason we should be doing that. One thing to really pay attention to, and here's a great example of the next concept I'm going to get into, which is permeable paving systems. Historically, we look at permeable paving systems, and the reason they're not so, they're costly. So that's the thing, is people look at them and they go, okay, I want a permeable paving system, but it's going to cost me $5 to pave this, $5 or $6 to pave this. Pavers are going to cost me $10 to $15, $12 to $15. Why am I going to pay 2.5 times the surfacing cost that it takes me to now versus an asphalt pavement? It doesn't make sense on the outside. But if you consider the impacts to the water treatment, the water quality, the runoff reduction component of the equation, paving systems are the way to go. Because, so here's a model of a job we did in Orange County. Just going, flowing through a focal point system, then into an R tank. We basically, everything goes through here. We have 250 square feet of focal point. We've got a 5,300 cubic foot tank. Traditional model, okay, great. Let's incorporate pavers. Let's incorporate truly not a paver. I hate the word paver, but let's incorporate a permeable surfacing that's truly permeable. We're going to cut your cost by half. And the reason is while this is $10 and it's twice the cost of that asphalt, I've now created a giant pond above my treatment system. So I have surge capacity. I can hold that water before it goes through my system, much like I was telling you earlier with decentralization. Hold on to that water where you can, then slowly release it into your system. Your system is going to go from 200 square feet to 35 square feet, and you're going to save about half the money. So on the outside, paver systems don't make a lot of sense because it's like, all right, well, I'm not going to spend $12 when I could spend $5. Think about it on the reduction of your storm drain cost, the sizing of your storm drain cost, the size of your biofiltration systems. You're reducing all of those across the board by implementing solid permeable paving technology. So Whitson is California Filtration is part of a network of regional manufacturers. We have tens of thousands of systems installed throughout the country. In California, we've done hundreds and hundreds of systems now, dozens of biofiltration, dozens of tanks, dozens of filtration systems. So, when I first started this, everyone's like, has Escondido done it? And then Escondido says, has San Marcos done it? Great. I know we want to make certain that the person next door does it, but we have now. So if you have questions about where we've installed, where we're designed, let me know. We're absolutely installed in a neighboring community or in yours. Talking about pavers. So why don't pavers work? Pavers don't work for a few reasons. The biggest reason is it's the void space. So even on a permeable concrete or a permeable asphalt, look at the void space. All the water is being forced. So what they do is they take pavers and they fill these gaps in with aggregate. or with sand. They sweep sand in those joints. You're reducing the void space. You know, permeable concrete, I think, is ridiculous. Whoever does permeable concrete is just, why? I mean, go to any parking lot that has permeable concrete, turn a tire on that permeable concrete, and watch that concrete dissolve. So A, it's going to clog. B, it's going to crumble. And so it's just not efficient technology. Small pore space. You know, the other thing that's a problem here in California is it's not like the East Coast where we get 85% of our water from the 85th storm. We get all of our water from very isolated storm events. We get 85% of our water from the 15% storm. That means, you know, look at it. It's basically 0.02, 0.02, 0.3, 0.1, 0.4, 0.6, 0.1, you know, oh, there's an inch. There's another inch. So we basically get, you've got 8 months of dust going into the pores of this permeable system. Then you get this sprinkling of rain. You get that 300ths of an inch in September. You get that 100ths of an inch in there. And we take that dust and we turn it into goop. And then we basically solidify it. And then all of a sudden you get one rain event and you're hoping it's going to flush the system. It's not. You're going to clog that system. In fact, the Brookings Institute says infiltration rate of porous asphalt and concrete will exceed 2,000 inches an hour new. But long-term rate, it will flow as low as 2 inches per hour. So you're basically doing something that you think is going to work, which you know for a fact is going to fail over time. So why are we doing it? You know, we're wiping sand into our paving systems to lock them together. Paver systems are expensive. Why are they expensive? Because we basically have to use an edge restraint. We have to do variable surfaces. We have to lock them together. We've got to put sand into joints. It's just super expensive, and it's a system designed for failure. You know, traditional paver systems, again, it's generally, you know, more expensive than asphalt. Oh, sorry, I already did that. Sorry, I threw a couple presentations together at the last minute. You know, instead of going with a paver system, go with a block system. You know, our pave drain block system always has a 1/4 inch gap. The flow rate is over 1,500 inches an hour, and it just doesn't clog. It's, you know, because the material cost is more expensive than the tiny little blocks. You know, this is like $3 or $4 a square foot for the material. We're about $6 for material, but our placement cost is so small because, look, I don't have to do an edge restraint. I don't have to put a curb next to it. So it's always got a 1/4 inch gap. It doesn't clog. You know, we put down a base section. We put down the geotextiles. We always bet it on geotextile. Go to a paver guy and ask him if you could pave right next to his block. I know the answer, and it's no. We want you paving against our block. It's a 50-pound block. We want you locking in the system. It's as structural as the asphalt. It's probably more structural than the asphalt, but you can pave next to it. You could drive on it. You can put the wheel right next to it. We want you paving next to our system. We don't demand a concrete curb around it so it doesn't clog. But what do? You get an architectural element that reduces the size of your storm drain system. In fact, it becomes your storm drain system. Do your parking stalls. We'll do enough. If you have permeability in your pavement, we're just going to do enough permeable pavement to infiltrate all the water you have to infiltrate. If not, we're going to use this as an actual storm drain system. We're going to break that subgrade one way or another. We're going to flow it into a biofiltration system, just like the model I showed you earlier. But now you have the same color palette you do of any other block, but you actually have a block that's functional. Pool decks, you know, trench drains. Why are we not, why do a cross gutter down an alley to flow off a project? You know, instead of using trench drains, why not use paved drain? This is a project in San Jose on First Street. Historic facility, a lot of flooding. They were going to spend $27,000 for a trench drain across this parking lot. Instead, we talked them into putting a $7,000 paved drain across the parking lot. We just line the bottom with an impermeable liner. We put a perforated pipe in it. It flows into the trench drain. We're done. Simple. You know, it's a really simple solution. You know, edges of roadway, sides of roadway. We're doing a bunch of this up in the LA area where they want more permeable surfacing. Well, this is the heavy duty traffic loading. And we've gotten rid of all the gutters, all the other stuff. This one's interesting. This shows you the power of paving. So in the University of Florida, they wanted to figure it out. They're like, okay, let's see how bad it is. They filled it full of soot. They soaked that soot. They raked it in. They clogged it in. They vacuumed it out. And it was still over, let's see, well, I mean, we started at 2,000 inches an hour, and then we're still over 1,800 inches per hour. And that's trying to destroy the system. We have systems up in the Sierras where they've done no maintenance. They just drive over it with a street vac. Just like this, instead of using a street sweeper, actually use a street vac. Look how dirty that is on the front end. Drive over it with a whirlwind, Elgin whirlwind. Gets rid of all of that pre and post. So you still have, it doesn't clog, you know, it would draw normal routine maintenance. So you have a paver system that actually functions. If you guys are interested to see, you know, there's grant funds out there for anybody, municipal people, if you're actually trying to capture water and put it back in the ground, there are grants that you can get. With our system, we could actually give you real-time data as to the amount of water you infiltrate with the pave drain system by using these sensor blocks in our system. So we could basically track the amount of water you infiltrate back into the ground. We have another permeable paving system. I'm going to go quick. We have another permeable paving system. This one's awesome. And the reason I like this one is because this is less expensive than asphalt. Comes with a 25-year manufacturer's warranty and is equivalent to 6 inches of asphalt over a structural section. U.S. military lands airplanes on it throughout the world. It's what the U.S. military and NATO use at forward operating bases. We use equine facilities, slope failures, channel lining. It's 100% open grid. It locks together. It's a low density polyethylene. So it doesn't break. It never becomes brittle. It won't fall apart. It basically flexes and moves, but it doesn't fail. So because it's a low density polyethylene, it basically moves a little bit, but basically it's equivalent to 6 inches of asphalt. Made out of 100%, you want to talk about sustainability? Made out of 100% recycled plastic bags. So this grid is made out of 100% recycled plastic bags. I'll show you another version of it in a second called blocks. We're going to, instead of using the concrete blocks to fill it, we're using 100% recycled tire rubber. Well, 95% recycled tire rubber with a binder. So now you have a paver system that flows at over 3,000 inches an hour, won't clog, that is less expensive than asphalt, 100% permeable to 25-year life, made out of recycled products. Don't confuse EcoRaster with all the other nonsense in the market. It's a complicated system. It's high density polyethylene, and it will fail, and it'll fail immediately. Any of these grid systems, if it's not a low density polyethylene, avoid them. They're going to claim they're going to last. They're not. We've got 25 years we're going to give you a warranty because we've never had a failure in 25 years. So what do? You know, for access roads, these types of things, temporary pavements, you know, they use these at fracking sites and oil recovery sites up in Canada. So you basically grade a road, snap this down, drive heavy trucks over it for 5 or 6 months, then they pick it up, they unzip it, and they put it on a truck and they move it to the next one. So it stabilizes even areas where you're not even putting down a class 2 aggregate. This is traditionally what we do. We dig a structural section, we put a geotextile membrane, crushed rock bed, we snap this on top. So what are we doing? We're doing parking lots out of it. I mean, this isn't the best. This is actually the most structural version of it, but 100% permeable surface. We fill it with 3/4 crushed rock. It holds all the rock in. The water goes directly into the system. And, you know, drivable surfaces, drivable grass, or don't put anything in it. I did this because you can actually see we cut it. So we can actually cut around joints and stuff. You know, clearly it supports heavy loads. In fact, it's in, you know, I think they want 72,000 pound axle load for fire trucks. We're 172,000 pound load rating on our system. So 2.5 times the fire truck ratings EcoRester will support. So the way to look at this is if you've got a, the best way to look at this design-wise, if you've got a 3-inch asphalt section over a 4-inch aggregate base, Class 2 aggregate base, as long as you're using crushed rock, 3/4 crushed, that has an R value of over 75, you can now replace that Class 2 with 3/4 crush, compact that 3/4 crush, get rid of your asphalt, put down EcoRester, and now you have 100% permeable surface. No changes in structural section, no nothing. You're just replacing asphalt or concrete with this, and you've got 100% permeable surface versus one that's not. Bank stabilizations. This is a 45-degree slope on the left-hand side. It's a slope failure. They just strapped this down, and it hasn't moved in 10 years. Channel linings. In Arizona, we're doing channel linings. The Corps of Engineers don't want us using hard armor on slopes anymore. So why are we not just strapping this down, pinning it onto that slope, letting the vegetation, flow through it? And it's a great channel liner. I was talking to someone from the city a few years ago about Choyas Creek. This is a perfect solution for them at a 1/1000th the cost of a riprap line channel. Just grade it, snap it, walk away. If you want something more attractive, we can change the aggregates, but also ADA compliance. This is the block system that we have. Oops, sorry. This is the block system, and what we do is we basically, it's got same thing, over 3,000 inch an hour flow rate. The water flows into the channels around the corner. We put 4 blocks in there. On this side, you can see, sorry, I'll change this real quick and I'll blow it up a tiny bit. You can see the rubber. So now we have a Cal grant study. We actually have a grant from Cal Recycling. We've figured out how to do this. Well, we're figuring out how to do it locally in California. But what was really neat with the person we're working through that actually developed the tire-derived rubber compound, it's 100% permeable rubber compound. So not only does the water flow through the system itself, it's actually flowing through the individual blocks. And so, this is a little more expensive than, say, this grid system. This grid system, the material cost is about $3. The placement cost is less than $1. So you're talking the same thing. You're talking about $4 or $5 to put this down. You're talking $4 or $5 for asphalt, or $5 or $6 for asphalt. So we're cheaper than asphalt. Here we're a little more expensive. We're probably closer to $7 or $8 in the ground, but we're competing with structural concrete. So instead of concrete, you now have a structurally equivalent section that's 100% permeable at the same cost. That's why I like EcoRester. EcoRester I just like, and the reason is because of a cost point. It's got to make sense financially. Storage systems, storage infiltration systems. I've got about 10 minutes, so I'm just going to be real quick. The difference between us and, a lot of people don't like modular cell technology, and the reason is there's been failures. In fact, we're building a 900,000 cubic foot tank in Visalia between now and the end of Christmas. We can build massive systems cheaper than you can do concrete. And also timing-wise, we can meet their aggressive schedule. But the reason people like our system versus everything else is because we've never had a failure. In fact, the reason I brought up the Visalia job is as soon as they announced to the industry that we're going to build this $4.5 million tank, they basically, all of the competition came out and said, you're going to put people's lives in danger. You're going to hurt people. And they said, and they gave these 4 studies of failed systems. Well, none of those systems were ours. In fact, 2 of the systems that they brought to the owner's attention to try to scare them away from our technology, our system replaced the system that failed. And the reason is we're the only system that bothered to get third-party ASTM and third-party AASHTO certifications. So all of our loading tables, all of our quality control, quality assurance, we've never had a failure. And so we'll go deeper than other systems. We'll go more shallow than other systems. So on my standard system, I'll start with 7 feet of dirt on top of it. And on the job in Visalia, I got an 8.5 foot tank. So I'm down closer to 16 feet at the bottom of the tank. With my SD version, I can have 10 feet of dirt on top of it. And I could be as shallow as 18 inches above it. But I can go with this, I'll now have the bottom of my tank at 20 feet. So I can go more shallow than anybody, I can go deeper than anybody. But what are we doing? We're doing the same thing that every other tank is doing. The difference is between our systems and the other systems, what are we wrapping it in? You know, are we wrapping in, are we doing an infiltration system where you use a microgrid in which we basically utilize all the rock and everything around, the water flows through the system? Are we doing it just a normal storage system and we're just going to wrap it in the woven or non-woven geotextile? Or are we actually doing rain harvest in which we're actually welding and seaming the whole system together? So it depends on what you're trying to do. But, you know, in a nutshell, we're basically able to, no difference. The system's all the same. Tanks are all the same, just what we wrap it in. Neat thing about our tank is we figured out all the maintenance. So we do maintenance ports, we do maintenance rows, we do 2 feet of crushed rock around, we compact our system in the ground, we protect it from the outside. We actually have maintenance rows in which we can isolate the pollutants inside of a tank and make it easier for us to maintain. So we'll snake down the spine of this tank, or we'll just flush water in each of these portals and bring it through and run it. So we maintain it like anybody else, any other tank. We can inspect, we can maintain. You know, this is a standard arch pipe system. Here's an arch tank. You know, look at the size of the storm drain system. Look at the size of the pipes going between these. Think about the cost it costs to build that Jiffy Lube. Think about the cost it costs to build these parking lots. When you're all of a sudden having to bridge over a system like this, it's going to be costly not only to install the tank, it's also going to be costly to pave on top of it, because you've got to now change the design of the pavement above the system. So isolate that system. You don't have to be flat. You can be tall. You can be short. You can avoid utilities. You can even avoid utilities after the fact. Like this is a job we did in which a water line went right through the spine of the tank. It's like, all right, fine, let's just build the tank around it. Who cares? There's a job we did in Orange, city of Orange last year. You know, they were going to tear up this entire parking lot, use Contech 84-inch vaults, torrent dry wells, modular wetland systems in this parking lot, about $1.2 to $1.3 million in 6 months. Or you can just do what we did, which is a design build contractor. We took this was a big giant concrete vault that was a water harvesting system that failed because when they built this BJ's, all the construction equipment broke that tank. So you can be 6 months and $1.3 million, or you can be 2 months and $600,000. You decide. You know, doing a lot of this in San Diego. There's a project, Tractor Supply. This one's interesting because what's interesting about this is they changed the grade after design, and this tank is now deeper than 7 feet. So they're panicking how they fix it. Well, fine, just put another module on top. So we effectively changed the depth of cover above the tank to below 7 feet. Simple fix, less than $1,000. So anyways, it's just, you know, this is the world we like to live in. You know, build a curve, you know, build a system along a curve. You can stagger your tanks, put pave drain on top of it, sheet flow everything to your parking lot. Eliminate all your area drains, eliminate all your grates, eliminate all, you know, think about the cost saved with eliminating all that storm drain system and just sheet flowing to a paver system. We have trash solutions. We have trash solutions that are certified by the state of California that are a fraction of the cost of what everyone else is doing. Everyone's doing automatic retractable screens. You know, it's a failed system. You know, I went out when we did this for the city of Thousand Oaks. I looked at well over 100 systems. 68% of the automatic retractable screens were broken. More importantly, look what happened. They were going to spend $91,000 to do what everyone else is doing. When we came up, we changed the screen design with Trash Guard. We saved them about 70 grand, about $64,000, which is a hell of a lot of money. So go small, go decentralized, go simple treatment systems. Curb inlets into our biofiltration. Here's a good way to get debris and trash out of your system as you're trying to leave a project. We're doing a lot of these at Hotel Del. Here's our focal point high flow biofiltration system. Modular system, decentralized, same as, you know, like I said, we've got tape equivalent certifications. We did a project with the Navy. These are the results. We meet enhanced requirements for tape certification, and we have the Navy study to prove it. So we don't have tape. We're in the process working with the Navy to get tape to basically approve the system, but we have the results and we have a tape quality study. In fact, we have 2 tape quality studies that show focal point will more than exceed the requirements of taped enhanced. So reduce the size. Here's a job in Chula Vista. You know, tiny little focal point, big R tank, utility conflict, we split the tanks, not a big deal. But this is the way you should be designing. Treat at the source, treat at the DMA. Have that water go into a focal point bed, do an expanded R tank, reduce the size of your pipe throughout your project. It's really simple. You know, streetscapes, we do a lot of streetscapes, we do a ton of, oh, I got about 2 minutes, I gotta stop. So green street applications, we're working with the County of LA. The County of LA loves our products. We're doing several projects and several properties with the County of LA, Department of Public Works, on their green streets applications. It looks a lot like this. You know, our tank below a focal point, you know, we do water quality and runoff reduction. And then this is our Fabco system. So like I said, our Fabco system is a cartridge-based system, but we kill the bacteria, like I said. We also do retrofits of existing storm drain systems. So instead of only having about 18 inches of treatment area in a cartridge, we can actually do 10 to 15 feet of treatment area if you have a really high bacteria issue. So trash solutions. If you guys really have metal issues, let me know. This is the system the Navy made. We control the Navy's patent. The Navy combined our focal point because they felt it was the best, most high quality pollutant reduction. So it takes the top up all the pollutants. But then when they run through the Navy patented material, we're bringing both dissolved metals and suspended metals over 97%. So we're basically taking really crappy water and turning it potable. So this is the space we live. This is the way we should be designing. Here's a project that won ASCE and EPA awards. That's one system now. This looks much like the project we're doing in South El Monte, where we're taking modular systems. We're doing permeable instead of doing the you know, a trench drain. We're doing pavers above our tanks. That reduces everything, and it all builds down to a tiny little focal point at the bottom of the project. So we're doing all the surge control above the system, and then we're slowly reducing the system as we go down. So award-winning, again, really cool project. Yeah, you know, I hope that, I mean, there's a lot of information. Like I said, every Wednesday, reach out to us, let us know. We'll actually do deeper dives. I believe tomorrow's presentation is on filtration solutions. Tomorrow's system is on filtration solutions. We'll do a permeable paving solutions. We do storage infiltration systems. And then I basically repeat this one. So if you guys are interested in either joining our webinars or if you want a specific project you'd like looked at, just reach out to us. But we're here to save you money. We're here to implement technologies, new technologies that, new technologies that will save you time, save you money, save you a headache, give you land back. And that's what you want as developers. That's what we want as engineers. We want simple, maintainable, affordable solutions that are durable. So it looks like I've got some questions. I'll stop sharing my screen and well, let me just see what the questions are. Yes, I'll go through these individually. If anyone wants to chime in, you could ask me verbally, but I'll go through these one by one. John, yes, that's exactly why we use Parjana. So we've done several projects in the Central Valley where they have hard pan clays. That's exactly what, how do I widen this? Let me stop sharing my screen. I'm going to cancel. Hi, I'm just trying to see, it looks like it's cut off. Oh, there it is. Are you using the storm design flow or the storm design volume meeting? What we'll do is we'll actually design your system for you. So if you have a project, Parjana will actually give you a preliminary design along with an estimate on what they can do to reduce your design flow. So they could do either one. So you give us the parameters and we'll design a system that comes up to it. One should not put pipes in it. No, understood. No, one should not put pipes under buildings. Yeah, I agree. You pipe that needs to go in the street, absolutely.
Hey,
I don't
Mitch,
know what. Yeah.
Mitch, this is John Tarascus. Just to follow up on that question, I review a lot of post-construction plans for municipalities. So I'm just curious, we have to look at the SDF or SDV. How would your systems typically be sized? Would it be volumetric or flow through?
You know, I'll be 100% honest. I don't know. Parjana, if you could send me your email, if you have my email, let me put you in touch with the people from Parjana. It's fairly new to us. We haven't done any systems in Southern California. They just gave us that territory. So I don't know the exact answer to that, but I could absolutely get you the answer. Would you mind popping me an email? Do you have my email address?
No, I really appreciate what you presented. It's given me a lot of good ideas, and I know a lot of developers who really could use this information. And so, yeah, not only just on Parjana, but also your infiltration systems. My question there was, yeah, I know your system can infiltrate, you know, extremely high flow rates, but what happens once it hits the subgrade? You know, are we counting on the volume capture of the infiltration device?
Yeah, we typically will pair our systems together. So, like we'll do a Parjana system. We were looking at a job in LA or city of Anaheim where we were doing an R tank system, and then we surrounded the bottom of the system had a Parjana on it. So we changed the flow characteristics of the actual soils below to get infiltration where there was not any. And then we did an R tank above it to do the volume control, basically the surge control. And then there's always overflows with all of our systems. So we'll always have an overflow off the system or off the top of the system. So like the job we're doing in El Monte, we're doing R tank below permeable pavers. And what's happening is the water is going to flow down the gutter line, go into our pave drain, into the R tank. And then when that system it basically gets full, the water continues down the gutter line, goes to the next system, continues down the gutter line. But most instances, we have an overflow. We almost always put an overflow at the top of system so that if we get such a rainfall, we don't want to create flooding. So we want it to move on and go away.
Right. Okay. Well, good. Yeah, I definitely would like to talk to you more in depth, but thank you for your presentation.
No, please, I would love to. I'd love to go over some, and we can go into some deep dives. Absolutely. You don't have to sit through the webinar. You and I can spend a little time together. Moving on with the questions. What type of maintenance? So we inspect our tanks annually. So we have maintenance ports. And in order for us, in fact, we just put it out, we demand that we inspect the system annually. Otherwise, we're going to void the warranty. But the maintenance port, it's a valve can. We open it up, we look inside the tank, and we have a sediment gauge that we stick down to the bottom of the tank. And then depending on the amount of sediment you have in the tank is when we need to maintain it. But we generally insist that every system we install has some type of pre-treatment. So the job at Outlets of Orange, we do trash. At a minimum, we'll do the trash guards at all the catch basins prior to the system because you do not want trash in our systems, really any system for that matter. And then, we really do recommend doing some type of treatment system before the tank. Certainly if you're gonna have a large tank with a lot of storage, you want some type of sediment control before you get into it. Let's see, how are the sizing infiltrations? That's a question for John.
I think we answered that question kind of already. Do you want to answer Elizabeth's question? I think that's the last one.
Well, this is regarding the permeable paving. So you're right. The 2,000 inches an hour is the flow through my system. What actually makes it into the ground is dependent on the permeability of the soils below it. So we're able to get the water off the surface into the ground. and depending on what we do with it. If it's an infiltration system, we generally put a microgrid on the bottom, or if it's a well-graded sand or aggregate, we'll just put the crushed rock on that ground. So as fast as the ground can put the water into the ground is really the true infiltration system, but the system itself will get 2,000 to 3,000 inches of hour off the surface into the rock. I appreciate the update photos and latest on it, including installation. Thanks, Jennifer. Yeah, I'm a little, 30-something years of building heavy highway, heavy civil projects tend to make me I kind of say it as it is. So I hope I didn't offend anybody. Cool. Well, if there's no other questions, please let me know how we can help. I know that was a lot of information in a very short window, but we're here and we're a service-oriented company. Don't think for a split second that we're not going to be here. We'll, regardless of the size, we help the small developer doing a Starbucks in Thousand Oaks, save a couple $1,000. We've done 7 different plan variations. Plan design changes. So we'll design all your systems. So if you give me flow volumes and a conceptual site design, we'll give you options. As you go through the design process, we'll design everything for you, all the way down to your working drawings and your AutoCAD. So we're cradle to grave, from concept all the way through budgeting. And if you want us as a design build contractor, we'll put all these systems in the ground for you because we're an A licensed engineering general contractor. So cradle to grave is our philosophy.
All right. Well, thank you, Mitch. Thank you so much for the presentation, at least for me.
Oh, wait, Elizabeth had a quick question. Sorry.
Oh, there is one more?
My apologies. How strong are the interlocking pavers? Well, there's 2 different types. The paved drain itself is a 50-pound concrete block. Easily HS25, no issues whatsoever. The actual interlocking paver system, I think you were talking about EcoRaster. The load rating on an EcoRaster is over 172,000 pounds per square foot. So it far exceeds fire truck loading, far exceeds, basically any loading you're gonna put on a system. As importantly, you can put these on very steep slopes without a failure. We put these on 20-degree slopes before under traffic loads and never had a failure. So the system's got over 200 million square feet in the ground throughout Europe and in the United States, and they've never had a failure in 25 years. That's why we'll warranty it for 25 years. Sorry.
No, that's fine. Awesome. All right. Well, again, for me, that was very informative. I think when people think of LID, we just have the basic, retention basins or, biofiltration systems or trench drain, French drain. So having all these new technologies and new ideas to think of when designing projects is really helpful. So thank you for that. And thank you all for joining us. I hope you learned something, and be sure to check some of our other classes out. We have some really great things coming up this week. So thank you so much and have a good day.
Thanks, everybody. Thanks, Jonah.